Hi, my name is Lexi and I will be teaching you about impulse and momentum.
Take a look at these two balls. The moving ball has momentum and the still ball does not.
So, what is momentum? Momentum can be defined as the quantity of an object's motion. It can be described as mass in motion, as it is measured as the product of an object's mass and its velocity.
Here is the equation for momentum, where m is equal to mass, v is equal to velocity, and p stands for momentum. This is the impulse momentum theorem. It provides that a net force multiplied by time is equal to the change in momentum. Just as according to Newton's second law, a net force corresponds to an acceleration, here a net force corresponds to a change in momentum. Take this ball and this ramp, for example. As the ball moves down the ramp, it accelerates due to the net force provided by the x-component of gravity. This means that the ball's velocity increases and therefore its momentum also increases. Watch as I drop this ball. The net force on this ball is provided by gravity, which acts downwards, and the air resistance is negligible. As I drop this ball, it accelerates due to this net force. Acceleration is defined by a change in velocity, and this change in velocity corresponds to a change in momentum. In collisions, momentum is conserved, or in other words, there is no change in momentum. This is due to the fact that there are no net external forces acting on a system of objects in a collision. The only forces are the forces that the objects apply on each other, which are internal forces, and do not contribute to the net force on the system. There are four types of collisions: an inelastic collision, a perfectly inelastic collision, an elastic collision, and an explosion. Momentum is conserved in all collisions regardless of the type, so therefore collisions are not classified based on momentum, they are classified with regards to kinetic energy. To begin, both inelastic and perfectly inelastic collisions have a loss of kinetic energy. A perfectly inelastic collision represents a maximum loss of kinetic energy. Here's an example. A 0.2 kilogram arrow is shot at an initial velocity of 20 meters per second and embeds itself in a 2 kilogram block of wood that initially hangs at rest. What is the speed of the system following the collision? The momentum before the collision and the momentum after the collision must be equal, since momentum is conserved. Before the collision, the momentum is the mass of the arrow times the velocity of the arrow, since the block of wood begins at rest. That is 0.2 times 20, which is equal to 4. After the collision, the block of wood and the arrow move together, so the momentum is 2 plus 0.2, which is 2.2, multiplied by v prime, which is the velocity after the collision. The velocity after the collision is therefore equal to 1.8 meters per second. An explosion is the opposite of an inelastic collision. An explosion means that there is a gain of kinetic energy. Finally, an elastic collision means that kinetic energy, in addition to momentum, is conserved. Well, that is momentum. Thanks for watching and learning with me.